We've looked at perpendicular bisectors of triangles. Now let's take a look at angle bisectors of triangles. Three angles of a triangle. If we bisect angle A, these two are equal. If we bisect angle B, if we bisect angle C, what do we notice here? All three of those bisectors are meeting at a point called the point of concurrency. It's a common point that they're meeting. That point has a special name. It's called the incenter. And this incenter is equidistant from the sides of the triangle, meaning PY equals PZ equals PX. Now notice something else. It's a perpendicular distance. Anytime you have a point to a line, it's always that perpendicular distance. So again, you bisect all three angles. Those angle bisectors will meet at a common point called the incenter. Now, will they always meet inside the triangle? Yes. Let's look at these. Different triangles. Bisecting all three angles, point P is inside. Obtuse triangle. Bisect all three angles, again, the incenter, meeting inside. All three right triangle, the point P, which is incenter, meet inside. Whereas sometimes with the circumcenter, based on the triangle, that point of concurrency can meet outside. But in the incenter, all three angle bisectors meet inside. They intersect inside the triangle. Now, there is something really special that I want to share with you about the incenter. The incenter is the center of the triangle's inscribed circle. A circle inscribed in a polygon intersects each line that contains a side of the polygon at exactly one point, like so. Notice this incenter is the center of the inscribed circle. It's sort of like the point of gravity that is like a center point, a balance point. That's this point, incenter. Now, knowing that, let's look at a problem. Line segment JV and line segment KV are angle bisectors of the triangle JKL. Well, if they're angle bisectors, then I know these two angles are equal and these two angles are equal. Let's find some measures. Suppose we were asked to measure VKL. Measure VKL. Well, let's see. I know these two are equal. I know these two are equal. But we want to actually find the measure of this angle in degrees. Well, if this one's 23, this one's also 23. This angle is 100. Remember that the theorem that the sum of the three angles of a triangle, sum of the measures, is equal to 180. So right here we have 23 and 23. So angle J is equal to 46. Angle L is equal to 100. When we add, we got 146. These two angles together should add up to, when I add it to 146, should add up to 180 degrees. So what I'm going to do is I'm going to subtract 146 from 180. This will give you 34. divide by 2, what do I get? 17 degrees. So this angle is 17 degrees. And so is this one, if we were asked. Well, we were only asked to find the measure angle VKL. We're also being asked to find what's the distance from point V to line segment KL. Remember that this point, which is the end center, is equidistant from all three sides. Well, I see that V is 9.8 from, that's the distance that this point is from this side. Therefore, V has to be the same distance from here to this side, which is line segment LK. So therefore, if this is 9.8 and it's going to be, I'm going to sort of sketch it, perpendicular, this distance would also be 9.8.